All right, so binomial experiment have these characteristics and identical independent trials. The independent part is probably the most critical piece right there, because what we don't want to do is have an experiment where success or failure influences the next experiment, because then they're not independent, and the odds for the second experiment are going to be different than the ones for the first. And that means that we can't as easily generalize it. There are tools for that, but not like this. There are only two outcomes: win or loss. Okay, there's no draw or anything like that, or you're not dealing with ties or or abandoning the experiment altogether or anything like that. Successes and failures, again, probabilities should all add up to 1. And if we go back to the only two outcomes piece, that means that the probability of success and the probability of failure add up to 1. And we are interested in the probability of k successes out of n trials. So we're going to flip 10 coins and see how many times, and see what are the odds of getting 2 heads. Okay. So in that case, k would be 2 successes. Okay, so as long as we understand our variables, we're ready to go. All right, so what we're talking about is our fair dice. Trevor, stop playing. We usually talk about fair dice and fair coins, the ones that are not biased. If I have to stop this recording to deal with your behavior, I will bring this recording to your parents' attention. Thank you. So, in this example, what I'm going to talk about is a biased coin, all right? And this biased coin such that I believe I made it 3. 70% of the time, okay, so it's a biased coin. 70% of the time it's going to land on heads, and since we know that the probabilities add up to 1, what obviously else do I know? 30% is tails. Is 0.3. Therefore, the probability of tails is equal to 0.3. And obviously the probability of head, I can state that explicitly. All right. Okay. So what we're going to do is we're going to flip this coin 3 times. And we're going to see what is the probability that exactly 2 tails show up. So we can write that as probability of t equals 2. Okay, the number of tails equals 2. All right, so when you're dealing with a small number of things, small number of trials, okay, again, oftentimes it's simple enough to do a tree, okay? So we will do heads, heads, tails, heads, tails, heads, tails. Okay. All right. We're getting to the point where anything more than this is probably becoming burdensome, but for a small number of trials, I should be able to ask you guys to set up a tree like this and come up with your values. It is totally within the realm for me to ask you a question that says, solve this problem using a tree, and then solve this problem using a binomial distribution. Okay, and I'm going to show you both of them, and we're going to do both of them in this example. Okay. So heads is a 70% chance. That's 0.7, 0.3, 0.7, 0.3, so on, so forth. All right. So this guy, this is 1, 2, 3. So 0.7 times 0.7 times 0.7 is what? What's 7 cubed? Hmm? Hmm? 49 times 7. Jeez, I'm good. 49 times 7. 28, 63, 343. You're not in this class. Oh. You're not taking HL1. I can tell you that. You're not. This is incorrect. And you're in the wrong class. Wrong teacher. Assess down there. He's in my Algebra 1 class. I don't think he belongs right here, right now. Okay. So now it's 0.7, 0.7 times 0.3. So 0.49 times. So 28 and 27, 307. Right? Right? And we can fill in the rest of these values. So here we have 0.7 times 0.7 times 0.3. Again, here we have 0.09 times 0.7, so 0.063. 2 sevens and a 3 gives me 0.147. 2 3s and a 7 gives me 0.063. 2 3s and a 7, 0.063. And 0.027. Pretty sure I got all that. Double check my math. Yep, I'm good. Okay. So the ones that we're interested in are which ones? Only 2 tails. I didn't specify what order they were in. So if I only cared about 2 tails, well, that's going to be right here. A tail, a head, and a tail right there. A tail, tail, and a head right there. So we can take those 3, add them up. 0.63 times 3, 189. Okay. Now, a little bit more. That did have a certain degree of work involved. Okay. But if I asked you for 30 trials, you certainly wouldn't want to do that. That's just a drag. Okay. So we have a distribution that we talked about last time. Okay. And as soon as we're all done copying. Y'all good? All right. So going back to the formula, that was n choose k. probability of A to the K, probability of B to the N minus K. Okay. Now, for this trial, what is N? 3. N is the number of trials. This should be in your notes from. So this is, what is K in this case? 2. Probability of event A in this case. So a success. What's the probability of a success? 0.3, because it was a tail that we were interested in. And the probability of a tail, and K, as we've already found, was 2. And the probability of B, well, that's the probability of failure. And that we saw was 0.7 to the first. Yes, ma'am.
Is event A also be what they're looking for?
Yes. And of course, success and failure is depending upon whatever problem we're talking about. All right. Okay, great. So, 3, choose 2. Which is what? 3, choose 2. Just 3. One, two, three. 1, 2, 3. Same answer. See how that all rolled out? So, being able to do a probability distribution is pretty straightforward if you remember that formula. Does anyone have their formula sheet? Can anyone take a look and see if it's in there? I think it is. It wouldn't be under the option topic. It would be earlier in the book. I think the statistics probability. Let's see. Mm-mm. Yeah, 5.6 binomial distribution. Thank you. Yeah, it's in the formula book on 5.6. All right. Okay. Who has a graphing or a TI calculator with them? Just show of hands. If you have an emulator, that's fine. Okay. If you don't have a calculator of your own, would you grab one, because I want to walk everyone through the syntax? For the rest of you, do you have one at home? Or, okay. I believe there is an app that emulates it. If you don't have that app, or if you can't get that app, if it's not for your phone, let me know, because I can give you the file, the program. Excuse me, please. Okay, so hello. Why is my calculator not working? What is going on here, guys? Huh. 1 second, guys. We're going to pause for technical difficulties. Okay, sorry about that. For some reason, my calculator wasn't working. Changed the batteries or something. All right, so the binomial distribution. Okay. To get to the binomial distribution in your calculator, you're going to hit second distribution, and then you're going to go down. Yeah. Up. So you're going to hit second distribution, and you're going to, where is it? Where is it? Oh, I just didn't hit it right. There it is. So normal PDF. Now, is it binomial? There should be a binomial. There it is. Yeah, binomial, not normal. We'll deal with normal. Okay. So you can scroll down to it, or you can hit alpha and then math to get straight to it. The format for it is and here we have n, the number of trials, p, the probability, and x being 2, or 2, excuse me. In this case, we talked about it as k. So what? There's a secretary's office on the side of that wall. Okay. So, number of trials, well, depending on what your operating system is, sometimes if you have an older operating system, you have to type in the values with commas in between them, like I wrote up there. If you have the more modern operating system, 2.55, it gives you the menu form. But number of trials we had was 3. 0.3 was my success value, and we were interested in 2 wins. And there you see it, 3.3 and 2 for this particular problem. And we get the same answer. So 3 trials. 0.3 was my odds, and I had 2 successes. Okay? That's how you would plug it into the calculator. All right. Now, sometimes we are interested in looking at all of the probabilities. So the probability of 0 heads, 1 head, 2 heads, 3 heads. Okay? And to do that, it's nice to put it all in a table. Okay? So, K equaling 0, 1, 2, 3. So, one variable in here. So, lowercase k equals cap k. Okay. That's saying the probability of the probability of that event happening. Okay. Sometimes you'll see as the probability of cap x equaling lowercase x. X is the probability, sorry, x is the outcome, and lowercase x is the iterator in this case. Okay. But here we're using k. It's the same thing. So, we can go ahead and do this in our calculator. All right. Actually, by the way, do you all know the second entry command? Second enter. It brings back whatever you wrote last time. So if you're only changing one thing at a time, it's nice to be able to do. So here we're going to do 0 wins. 0.343. 1 win. 0.441. We already did 2 wins. That was 0.89, so here's 3 wins. And to graph that, would look something like that. Now, I just want to see something myself. Oh, wait. There they are. Okay, so it can be done. If you're trying to build this table and you want to do it quickly, okay, so what I did was this. I created a list. 0, 1, 2, 3. So if I had, like, if I wanted you to build a table of, say, 10 values, 10 trials, okay, and seeing what that would look like, this is how you would do it. You make a list. 0. If you want, let's do it for 10. Okay, you don't have to copy this down, but you should at least watch the steps. Okay. So, lists are great. To create a list, there are different ways of doing it. One way to make a list is to go stat edit and actually manually enter it in. So I'm going to clear all this stuff out from. old tests and stuff. Okay, so if you have anything in there, go ahead and clear it out, and we're going to go ahead and make our list of 1 through 10. Like I said, there are other ways of doing this, but with a small number of trials, it's just as easy to do it by hand. Okay, so these are going to be our X values. Okay, these are going to be the number of successes. Oh shoot, I didn't include 0. Yep. Now, by the way, to put that 0 to the front of the list, okay, go to list, operations, sort ascending, list 1. And if we go back, you'll see that it's been put up at the front. Okay, sort ascending and sort descending are nice little tools. All right, now what we want to do is we're going to run this same experiment. Okay, the same probability distribution with 10 trials and graph it. So I've already done it once. Okay, so you can hit second entry of yours, go back to where you had one of your experiments, and instead of putting in a specific number of victories or successful tails, we're going to plug in a list. You get to the list by hitting second L1 or second 1. Are we all where I am or heading there?
Like order thing you did in calc.
Yeah, so now you're good. Is everyone there, or does anybody need help? Let me help you out. Where?
To get list 1.
To create list 1?
No, I already created this one. But to get binomial PDF and then list 1.
Okay, so entry. I can't. Okay, and then go back
Okay.
and replace the 3 L1.
Where's
So
it?
second, a second 1.
Thank you.
Yeah, and now hit enter. And you'll see, did everyone get to here? Is anybody having troubles? Okay. And I get a whole bunch of values, right? And what we want to do is put that into a new list, store that. So we hit the store key, and then second L2. Store is above the on button, and then second number 2. And it'll just basically tell you, yes, I have done it. We go to stat edit, and we can see our lists. Oh, what? Wait, 1 second. What did I miss? Why am I getting zeros here? What have I forgotten to do? Change it to 10 trials. So let's quit, go back and fix it. Oh. You can use the insert key in order to squeeze that 10 in there. And now we're going to store it as list 2 again. So if you're flipping this biased coin that doesn't like to land on tails, you can see that you should get some tails a couple of times. And by the way, notice that the top of it, the most of it, is about 30% of the time, 3 out of 10, roughly, right? So now it's down, and you can see that getting 10 tails is going to be really, really rare because it doesn't like to land on tails, right? It's by heads. So now if you want to visualize this, because you want to see a graph, quit, head on up to second stat plot, which is y equals. And we're going to turn on one of our graphs and put in our values. So hit enter to go into plot 1. We're going to turn it on. We're going to choose a nice, scatter plot rather than a connect the lines line plot. Notice that we're putting in L1 and L2, list 1 and list 2. Those are my x and y values. Okay. Okay. And now, when we graph, you're not, oh shoot, I've got something left in there. Now, normally your graph would look like this, but we need to change our window so that we can see it a little bit better. So one feature that's nice is zoom stat, which is 9, zoom 9. Are we all getting this graph? Who's not?
It keeps on doing error whenever I try to replace.
And then that's 9.
Because you're using a decimal, not a comma.
Yeah, I know I did, but I put a comma there, but it just changed to decimal right now.
Closer.
Again, because it's got a comma. Ten comma 0.3 comma. Sure. Yeah. Go ahead. So this is how we begin to see visualization of these odds. Okay? Impossible? But being able to visualize your data is important. Okay? Okay, so we can solve these kinds of problems in multiple ways. Okay, so now, if we're interested in a slightly different question, let's stick with this 10 coin example, 10 coin tosses. If we wanted to find out what is the probability that at least 3 tails show up, okay? So now we're going to slightly change the problem. Now we're doing 10 trials, at least 3 tails, excuse me, 3 tails. So if we're talking about at least 3 tails, what we've got here is 3, 4, 5, 6, 7, 8, 9, and 10. Okay, the probability of any of those events occurring. Okay? There are different ways of doing this, and they should, first of all, if you've already made this table, it's literally just a matter of adding up the probabilities off of the table. Okay? But another way of doing it, a slightly different way of doing it, would be doing what is called, well, first of all, if we were to add up all 10 and in fact, we can see that. We can go to second list, operation, math, sum, list 1. No, not list 1, list 2. Okay? So one way we can do it is say, all right, what I'm is taking out things rather than adding up stuff. We can say not 0, 1, or 2. Okay? So we can find out what 0, 1, and 2 add up to, and then subtract it from 1. Does that make sense? Because we're saying not those. If they all add up to 1, let's just subtract out the 3 that we don't want. Okay? So we can do 1 minus No, you really don't do it this way. There is an easier way. I'm just showing you the process basically of, well, not 0, 1, and 2. That's one way of doing it. But what we're really interested in is adding up elements of my list. So, but do you see how it's the principle of what we're doing here is we're subtracting out the values that I'm not interested in. Okay? So, now let's go here for a moment and talk about this syntax. Now, what if I wanted some of these numbers, but I really didn't want to have to copy them all down? And I just wanted to pull one value out of a list so that maybe I can talk about it. Okay? Here's how you do that syntax. You go second L1, 1. Not L2. Probably. This is the first element in that list. Here's the second element in that list. You see? So it's almost kind of like function notation. Okay? Some of you guys know these calculators really well. Others of you might not. So I just want to make sure that you are comfortable using the calculator, because it is a tool for your use. It's just abusing it for simple stuff is what I want you to avoid. But when you're doing this big, nasty, crazy decimal stuff, it's important to know how to use it properly. Okay? All right. So what we're interested in is the 0th, the first, and the second experiments, right? Which is basically the first, second, and third terms in my list, right? So we could do it like this. So you see how I did that? That was, instead of doing the binomial thing 3 times, once I've made my list, I can just pull elements out of my list this way. Yeah, the first, second, and third numbers in the list. Okay? Now there is another tool if we have a lot of them. What if I wanted, to do this and say, and maybe make my life a little bit easier, and I wanted to accumulate these values? There's another distribution in here called a cumulative density function. Okay? Yes. Well, it's the first element in the list, which is the 0th row. You see, but yeah. You see, I want the first, second, and third numbers, which are corresponding to 0, 1, and 2. Good question. And by the way, before I even go into the cumulative density function, there's a nice tool. It's in your lists, in your list command. Take a look at this. Second list, operations, cumulative sum. And I'm going to store it as store 3. So I'll show you what this means. If you look at list 3, what's happening is that I'm adding I'm adding each value as I go down. And you'll see that it approaches 1. Okay? And in fact, go to stat plot, turn it on, and put it for list 3. There you have it. What's happening in that second curve, the ones with pluses rather than boxes, the boxes were the original individual values. But what's happening here is that I'm accumulating each time, you see? And as I accumulate, if I'm adding and adding and adding each value as I go down the line, I'm approaching that value of 1. Sure. So what I did was I went second list, operations. Okay, so stat and list are the same button, but 1 second stat. I go over to operations and I go down to cumulative sum. Cumulative sum is a nice little tool. Okay. So I did cumulative sum of list 2 and then I stored it into list 3. So that I could visualize it. Okay? And then I turned on stat plot, turned it on, said X's and Y values, and then I zoom stat. Are we okay? We'll make sure everyone's with me. Yes? I went to second y equals, which is stat plot, turned it on, went down and made sure that I was dealing with list 1 and list 3 for my x and y values. And then in order to get my window correct, I hit zoom 9, which is zoom stat. You okay? Sure? Okay. All right. Are we cool? Now, believe it or not, there's another way to do this. And it's called the cumulative density function. Not PDF, but CDF. Okay? Now, second binomial cumulative density function. Cumulative distribution function. That's what it is. Sorry. We're going to do 10 trials. The odds are 0.3. Okay? And we wanted the first 3 trials, right? So x equals 0, x equals 1, x equals 2. And that's the same value that we got earlier, I hope.
So it's 10.3.
We did 10 trials, the odds are 0.3, and it's up to 2. Okay? And there it is. That same value. Huh? 2. Because we were looking for at least 2 heads. Oh, sorry, at least 3 heads, right. So we didn't want 2, we didn't want 1, and we didn't want 0. So we're 1 minus it because it's all of the probabilities except for them. Do we see how I made that? Okay. Okay, so let's do a real example again. Yes, ma'am. PDF is a single value in the table. Cumulative, the CDF, is when you're adding up everything up to that value. So, let's do this. This is definitely not, with 8 possible picks. Okay, we have 8 people that we're picking. We are not going to want to make a table for this. I mean, not a tree. We don't want to make a tree for this. This is way too much. Let's go ahead and do, first of all, is this a PDF or a CDF? Are we adding them all up, or are we looking for a certain value? A PDF, it's a specific value. Okay, so let's use our formula. N is what in this case? 8. K is what? What's going to go right in here? The probability of a win. The probability of a win? 0.35. And we have 3 people doing it. What's going to go in here? To the 5th. Okay? We good? Okay. Now, putting the binomial, putting the binomial coefficient in if you're using the calculator, okay, go to, now, the number in front would be 8, and the number at the end would be 3, 56. We can do that math algebraically. We have 8 factorial, 3 factorial, 5 factorial, 8, 7, 6, 3 times 2, 56. Okay. So, by the way, that n choose r feature right there, that binomial coefficient, if you're, say, for example, you're looking for, you want to build, say, one whole row of Pascal's triangle, okay? You could use this, but you would have to do it for a whole lot of values, and that's a bit of a drag. But as you probably can guess, there's a shortcut. If we wanted the 8th row of the Pascal's triangle, this is how we would do it. Go to y equals, and now go to, you would do math, and choose r, and you're going to put 8. Oh, I lost it there. And x, because that's the thing that's going to change each time, you see? And if you go to your table, you'll see it. Second table. There they are. Oh, there they are. Notice it's not defined for negative numbers, but that's the list of coefficients on Pascal's triangle. To see one that's probably a bit more recognizable, one, 3, 3, 1. Okay. So that's a nice way to get the whole list of coefficients if you need it. But nonetheless, let's clear out of that. So I have 56 times 0.35 to the third times 0.65 to the fifth, and we get that. So the probability, yes?
You're probably divided up.
Oh, because your starting values are really way up there. So we're going to go to table setting and starting at 1. And now try it. Yeah, 0. Yeah, guys, if your tables are weird looking, you should recognize the table setting button. Okay, the table setting button is quite useful, especially if you're talking about showing that something approaches a value. Okay, and when we get more into calculus, when we talk about limits and things like that, where we are creeping up on values, we're going to revisit this again. Okay. All right. Now, if we were to do that at binomial, yeah, so we would do 8.353. And we get the same thing again. Okay? We cool? So algebra versus technology. Hmm? For the binomial? 3, because we were looking for 3 people. It's always the bottom number. First number is the top, last number is the bottom. Yeah, with the odds in the middle. So now my next question, same group of people. So this is the probability of k being less than or equal to 3. So now, how do we do this? Cumulative density and we want 0, 1, 2, and 3, right? Uh, Cumulative 8.35, at most 3, 0.706. Okay, and remember, we're always going to have 3 decimal places of accuracy for IB. Now, what if I had said to you, at most 3 of 8 people don't favor the restrictions? Yeah, 1 minus that, okay? Because if you don't favor it, then that's basically saying it's, take it out. You could also do this. That no. Yeah, no, it is, because if I'm saying 3 people don't, at most 3 people don't want the restrictions, that's this. I'm changing my odds because now I'm looking at, now I'm defining success as the 0.65 odds rather than success being the 0.35 odds. Okay? No, it's the other end of the curve. You see, 1 minus the original number, that would be at least 4. Okay? But if I'm saying at most 3 don't want it, then what I'm basically doing is, instead of saying a success is 0.35%, yeah, it would be the 0.65%, because I'm changing what success means. Okay? I'm sorry? No, this is correct now. Yeah. And in effect, what I'm doing that way when I say at most 3, at least, at most 3 would be these values added up. Okay? The 0th case, the first case, and the second case. 0, 1, and 2. But if I say that, if I change my odds, now basically what I'm saying is these being added up. And that's why it's such a small, because it's the last 3 values being dealt with. So that's a little weird, because now we're talking about approaching this curve from the other way. Okay. All right. Got a couple more examples to do, but I would say that episode of the Ronco Show is complete. And this episode has been brought to you by the binomial, CDF, and PDF functions, and the number 2.